The notes for 1.3 are a review of solving lots of different types of linear equations. There are some definitions and properties here that you can review. In solving equations, they can have different steps depending on the number of operations that need to be performed to get you to your answer. So here in example 1, two people solve the equation differently. They get two different answers. Which student solved the equation correctly, and how do you know? So the original equation was negative 2x is equal to 8. The negative 2 is connected to the x by multiplication, and so division would be the correct step to undo that. So in this problem down here, Miguel solved it correctly because as you look at it here, he divided both sides by negative 2 and arrived at the correct solution. His counterpart, it looks like they added the 2 to both sides to get the answer to the question. And so in this example right here, we can say that Miguel is correct. You need to divide. And then the second part of the question asks, how do you know? So just a reminder that you can plug it in to check that you got the correct answer right. Anytime you solve a linear equation, you can always take the number that you got and plug it back into the problem. So in this case, if I did negative 2 times negative 4, negative 2 times negative 4 gives me 8, and so that works as the answer to the question. So plugging it in to check the answer lets you see whether or not it's right. If you plugged in a 10, negative 2 times 10 would give you negative 20, and that doesn't equal negative 8. So that's how you know that this person did it right and this person did it wrong. In example number 2, we're doing this part here. It says check whether the given value of x is a solution to each equation. So for A, for x equals 4, I'm going to plug in the 4 for where the x was in the problem. So I'm just plugging it in here for where there was an x, and then I'll simplify from there. 12 minus 1 equals 6. And so notice how I keep the 6 the same over here, and I'm just simplifying on the left-hand side. Since 11 does not equal 6, we can conclude here the answer to the question is no, x equals 4 is not a solution of that equation because these two numbers weren't the same. Over here in the second example, so again, I'm just plugging the 2 in for where the x was into the equation that was given, and then I'll simplify the left-hand side. Let's see, negative 8 plus 3 gives me negative 5. And so on this one, because the two numbers are the same, we conclude that the answer is yes, so x equals 2 would be a solution for this equation. The properties of equality let you go from step to step in simplifying an equation, in solving an equation. Brian forgot what he did to solve the following problem. In the right column, explain to Brian what he did to go from one step to the next. So if this was the original equation, to get from here to here, these two like terms were combined, and so when you added together 2 and 3, you got 5. So the first thing he did was he combined like terms. To get from this step to this step, the 1 got added to both sides, and so that's the addition property of equality. And if you want to, you can abbreviate that as POE, or you can write out the words. So the 1 got added to both sides. That was the addition property that let him get from this step to this step. And then to finish, both sides got divided by 5. So the division property of equality is what lets him answer that question there. So you're writing a justification for each step. When you solve equations, just make sure that you show your work. You're going to perform opposite operations to isolate the variable and then indicate your answer to the question. And so when you see division, you'll perform multiplication to answer the question. Sometimes equations like these first two just have one step that you need to do to solve them, and then other times, like the following equations, there's more than one step that you need to do. So just be careful. Don't be too proud to use a calculator. This is probably a helpful time, especially because so much of this first chapter is review. It's a really good opportunity to stop and pause the video, try the problem on your own, and then compare your answer to see if you got the correct solution. Be careful on D. A lot of people forget that the sign in front of the number goes with the number. So on this one, I'll actually be subtracting the 4 from both sides. So negative 5z is equal to positive 35. And then I'll divide both sides by negative 5. So z equals negative 7. here on E, I'm going to start by performing the distributive property. And then once the distributive property has been performed, there's no more parentheses in the problem, and so then from there you can just follow the steps to solving the equation. So on this one I added the 15, and then I divided both sides by 3 to get D equals 10. Today in the notes, I'm not going back through and substituting in these answers to check on every problem, but remember, like in the example of a test, you could always go back and put the 10 here, or in a different problem go back and put the value of the variable in and check and make sure that you got the right answer to the question. 7t minus 21 is equal to 2t minus 18. On this one you have to be careful. We'll look at more at these on the next page in the notes, but this one has variables on both sides of the equation, and so we'll practice this more coming up. But on this one, you need to use opposite operations to move the variables together. And then add to both sides. So 5t equals positive 3. And then on this one, when you divide both sides by 5, it's okay to get a fraction. A lot of times as teachers, we pick problems that work out to be whole numbers. It doesn't necessarily mean you did it wrong if you got a fraction. If it's a super weird fraction, though, you just might want to go back and check your work for the problem. And then speaking of fractions, on these last two problems, they both have something with a fraction that's going to need to be addressed. I like to encourage you to, in this first one, minus the 8 to both sides, get the 8 over here, and now we can deal with the fraction. If you want to get rid of the fraction so that you don't have to worry about it anymore, you can multiply by the number in the bottom. So on this one, you times it by the denominator, so I'm timesing both sides by 5. The 5's cross out over here. And now, when you multiply both sides by 5, there's no more fraction left. So it makes this final step of dividing both sides by 4 a little bit less complicated to sort of understand. So G equals 15. On this one, I can't move the 4 over first because the 4 is also on top of the 3. So I'll start by multiplying both sides on this one by 3 to kind of get the numerator unlocked from being over that denominator. Just don't forget to multiply this side by 3 as well. And then by multiplying both sides by 3, now there's nothing left that you need to remove. So you'll minus the 4 from both sides, and then finish by dividing both sides by 2. So by choosing that special number to multiply both sides by in the beginning, you get rid of the fraction, and then you don't need to worry about it for the rest of the problem. In example number 4, it says solve for x in the rectangle below and then find the length of each side of the figure. Look at how I went ahead and set up my equation for this one. It's a rectangle, so I know that the opposite sides are congruent to each other. And then I'm told that the perimeter is 32. So look at the equation that got created down here. 2x minus 7, so the bottom side, plus x minus 1, the side that's over here on the right, plus the 2x minus 7 that's not labeled on the top, plus the x minus 1 that's not labeled over here. And because I was told at the beginning that the perimeter was 32, that means that all 4 of those sides are going to add up to equal 32. From here I can combine like terms. So 2x plus 1x plus 2x plus 1x, that gives me 6x. And then negative 7, negative 1, negative 7, negative 1, that gives me minus 16. And that's equal to 32. And then I'll go through and I'll solve that equation. So I'm going to get 6x is equal to 48. And then I'll divide both sides by 6. And 48 divided by 6, when you do that division, you're going to get x equals 8. So that's one of your answers to the question right there. The other thing that this question also wanted you to answer was it wanted you to figure out the length of each side in the figure. So x equals 8 is part of my answer, but now I need to go up here and I need to do the rest of the work. 8 minus 1, so that side is 7, and then I need to do the work for this one too. Let's see, 2 times 8 minus 7, and so that turns into, I should be working vertically, 16 minus 7, so that gives me 9 for that side. So the 4 sides of the shape are going to be 7, 7, 9, and 9. And you can write that out in any order. That's just one way that you can write the other answer to the question. But it's important to make sure that you recognize that they do also want you to go back and plug it in to find that answer to the question. Here we're going to have some more practice with solving equations with variables on both sides. If variables are on the same side of the equal sign, you combine like terms with the signs that they have. So to solve this equation right here, I would combine my 5x and my 2x, and then I would go through and I would finish solving the equation from there. So 3x equals 12, and then x equals 4. That's like most of the equations that we practiced solving on the front of the notes today. This one's different, and we saw a little preview of that on the notes on the other side. Notice how the 8 and the 2, 8y and 2y, they're on opposite sides of the equal sign. So to combine them, I can't just combine like terms and get 10 because they're on different sides of the equal sign, so that means a different operation. I need to subtract the 2y from both sides. So 6y plus 4 is equal to negative 26. And then from there, I'll proceed like I'm used to, negative 30. And so y equals negative 5. But it's important that you recognize that the work that you need to do to solve those two problems is different. In example number 5, we're going to decide whether we would use inverse operations A or combine like terms B to collect the x's when you're solving them. So in this one, the x's are on the same side. And so when they're on the same side, you're going to combine like terms. So you would B, combine like terms when you were solving that one. Look at this next example though. You see how on this one the 3x and the 2x are on different sides of the equal sign? You would need to use inverse operations to get them collected on the same side of the equal sign. On this one, all your x's are on the same side, so you would be combining like terms. On this one, you have x's on different sides, so you would need to use inverse operations. And then on the last one, you have both, because over here you would be combining like terms A and B. So on that one, you would need to use both to get your x's together. It's helpful to practice whether the equation has x's on both sides or just on one side, because it's a very common mistake that gets made that you have x's on both sides of the equation, both sides of the equal sign, and a lot of times people just combine like terms. So on this one, the mistake that got made was the person combined like terms but they should have used inverse operations to solve. And so to solve it correctly, we'll perform that in the space down here. Whenever there's a variable on both sides of the equation, I like to draw a line to signify where you're moving your x's, but again, that's not necessary. X plus 2 equals 12, and then minus 2 minus 2. So the correct answer for this question should have been x equals 10, not x equals 2, like the original student got as their answer. Sometimes when an equation has variables on both sides, it's possible that it could result in the equation not having a solution. And so that will happen in some, but not all of these problems. 2x minus 8 equals 2. And then once the variables are collected, we'll go through and we'll finish solving for x. So on this one, we'll get x equals 5. So this problem has one solution. X equals 5 is the one solution that makes it correct. There's kind of a tendency to always move the variables to the left when you're solving, but that's not something that must be done. Remember, there's lots of different ways to solve equations that you can arrive at the same answer. This equation has one solution, x equals 2. On C, we're going to be careful because we're going to start by combining like terms over here on the left-hand side the right-hand side before we start. So 9x minus 2 is equal to 9x minus 2. You might notice here in this step that the two sides match exactly. That's a hint that something is different about this problem. I'll subtract the 9x from both sides to move it together, but what happens is the x's cancel out, and so what you're left over with is negative 2 equals negative 2. Now that's not the answer to the question, but it's something that you need to notice before you do answer the question. Does negative 2 equal negative 2? Well, yes, it does. And so in that case, it means that any number is an answer to the question. And when an equation has every number as an answer to the question, we write all real numbers as the solution. So again, that happens when the x's both cancel out on both sides of the equation, and when what you're left over with is a true statement. You might even put a little check mark here to to remind yourself that it means that that's true. Over here on the final example, when I subtract the 3x from both sides, the x's are going to cancel out just like they did over here in this step, but look at what you have left over with negative 7 equals negative 16. So that's not a true statement. Negative 7 does not equal negative 16. You might put a little like x here to indicate that you acknowledge that that's an incorrect statement. And so when the two numbers left over aren't the same, it means that the answer to the question is no solution. There's no number that makes this equation true, and so it does not have a solution.